Since you are already familiar with several popular investment alternative analysis techniques, and many of the nuances, many of the points are common between all of them. So in each new example, I try to focus on the new parts, on the parts that you are still not enough familiar and they may be new to you. So in this example that you see in front of you, the present worth of benefits have already been calculated. So that's the point I'm saying. Here it is not asking you to calculate the present worth or calculate the initial cost or anything. It is already, these things are already calculated and are provided to you. So we can focus on the incremental analysis part of it, that I agree with, that it still needs more practice. Okay, so we have 6 investment alternatives, and maybe it is a public project that they have the initial cost and also they have monetized the benefits. So we have 6, and the benefit over cost is also calculated. It is not a big deal. Just when you divide 7,330 over 4,000, you get this 1.83. When you divide 4,700 by 2,000, you get 2.35. So it's not a big deal. It is just benefits over cost, and you have them. But when you want to use the benefit cost ratio analysis similar to internal rate of return analysis, you should go with incremental analysis. So the first thing you are going to do is rearranging the projects you have according to their initial cost. So when you see here, the least expensive project is D with the initial cost of $1,000. The next is B, $2,000, and like that. So here we rearrange everything as you see. Okay, from this part on, I want you to stop the video and try to apply incremental analysis according to the things you learned. So what you are gonna do, you are gonna first get the benefit over cost of the cheapest one, that is the 1.34, so it is acceptable, so it's gonna be defended. Then you go for the next one, that is B. But for B, you are gonna calculate the differences. So B minus D would be a case that 2,000 minus 1,000 would be the initial cost differences, and after that you go for the benefits, and then you calculate the delta, B over delta C, and if it is greater than, and like that you continue. Okay, don't be afraid of making mistakes, error, or when you see the answers are different from the answer I'm showing you. No, the fact that you are trying your best and trying to get your own answer, your own way of thinking, that's great. So absolutely do not worry about the wrong answers you are getting. It is not exam, it is not project, it is just learning area. I know that when you see the answer, you completely understand it, but you can make your experience, your learning experience, more genuine while you first do your own decisions, while you first make your own decisions, do your own answers, solutions. In that way, you get a better feedback from your work. Okay, so here it is the sorted one. And as you can see now, here we have 5 options. F has been crossed out because benefit over cost for F is smaller than 1. So now here we start with D. And I'm going to show the answer shortly. So is D acceptable? Yes, D acceptable. So D become our new defender. Defender is D, sorry. And after that, we go for B minus D. And if the result is greater than, equal or greater than 1, it means that it is worth spending that $1,000 extra and do project B, because the return on that $1,000 extra is greater than the cost we have already incurred. So I'm going to show you the answer and we are going to discuss it together. And if delta B over delta C is not greater than 1, so it means that we should stick to our defender. Okay, here we go for B minus D. B minus D would be 2,000 minus 1,000 for the initial cost and 4,700 minus 1,340. What would be delta B over delta C? 3.36. That's a great ratio, and it means that D is not our defender anymore. Now the defender is B because it proved that that extra investment of 1,000 is worth it. So D is out. D is out. Now we have B as the defender. So we are going to now compare A and B together to see if that $2,000 extra to get A is worth it. So 4,000 minus 2,000 to get the differences in the initial cost, and 7,330 minus 4,700 to get the differences regarding the benefits. So we get the benefits over the delta, delta benefit over the delta cost. The ratio we get is this one. That's a good ratio. So it means that A just beat B. B out, and defender is not anymore B, and the defender now is A. Now we go for C. C is the challenger now, to see if it is worth to go with 2,000 more investment, initial cost, to get 4,000 to 6,000. As you can see, C minus A, 8,730 minus 7,330. The ratio is not good. So it means that C lost it to A. And the last one is between E and A, and again the same thing. E lose it, and A is the one that we choose, the one that we select. It is benefit cost ratio analysis. It is really not a new technique that we are discussing, because when you are working in this field, when you are dealing with comparing options, making decisions in the world of finance, everything is connected to each other. And when you learn a new technique, it raises all your perspective to the financial problems to a new level. So now that you learn about benefit cost ratio, it is not just an independent technique that you are going to use it only in the situation that you need to use it. No, it raised your understanding. After this, you are a better, you are a deeper, you are a more experienced financial analyzer. And that's the reason I always say that be greedy regarding learning when you are working in this field. It is an interesting way of modeling benefit cost ratio in public sector. As we said, it is not that way directly monetary. So you see here, it's some innovative way of doing the model, and it says that the benefit part is all consequences to the users or the public, if they are benefits or even if they are disbenefits. Benefits like faster traffic, safer travel, healthier weather, and this benefit is like construction delay or inconvenience for the neighborhood or that type of thing. So in this model, it says put all of the things for the benefit, and for the cost, all the consequences to the sponsors or government. Again, you cannot generalize this model to everything, because when you are working as a financial analyzer, my friends, you constantly need to be very sharp on your critical thinking and on your analytical thinking, because you may come up in a situation that it is completely unique in its own kind, and you need to be able to come up with your own idea and style to model if you should put it on the benefit, how you need to monetize it, or anything like that. The most important things that I can tell you, make sure you are good with the logic, because when you are in the logic, it means that you have the best infrastructure for making your decision making. That foundation in your mind, in brain, is the most reliable infrastructure that you can build for your future decision making in this field. Before you start working on this example, I need to clarify some points about it. The first point is, this is a governmental project. So when it is governmental project, BC ratio analysis is the best. In governmental project, we still need to use interest rate to make sure the time value of money has been included in our analysis. When we see the details of the items here, we have annual maintenance. It is obviously cost. And we have initial cost. It is obviously cost. So it goes at the bottom of the fraction. Annual maintenance, absolutely cost. Uniform annual benefit. So since they are making the road, the annual benefit would be for the useful life of the project, that is 15 years. And it says that there are two projects, right turn and left turn lanes. And here is the uniform annual benefit, 1.6, and construction this benefit. About this benefit 900K, it is already the present value. So while you are doing this example, consider this 900K as the present value. And that's it. Now, when you want to do this example, you have two options. You have two alternatives. You go and make right turn lanes or left turn lanes. And here it is giving you the details, but just one point. For left turn, for the initial cost, here it is just to remind you, when you are using BC, you need to do incremental analysis. It says that right turn lanes project is the cheaper project, and the incremental data that we have in initial cost is 3 million. So it means that left turn lanes cost us 11.9 million. Okay, but we are not going to use this in our calculation. We are going to use this 3 million. The same way for annual maintenance. So it means that here that the annual maintenance for left turn lanes is 225K. But these ones are the actual value, so you need to calculate the annual, the incremental value yourself. And let me put it for you here, 0.6 million. And for this one, it would be 1.2 million. And the incremental, and it is 15 years. Okay. So go ahead and do the calculation and come up with the suggestion, advice that you are pro right turn lanes or left turn lanes. Stop the video. First we start with right turn lanes because it is the cheaper option that we have. And here we have BC ratio for right turn, present worth of the benefits over the present worth of costs. We go for the absolute values. The present worth of benefits, for the benefits we have this 1.6 million that are annually happens for 15 years. So this part that you see, 1.6 million, 15 years, 10%, you get the present value. Also, you have the present value of these benefits during the construction. So here you get the net value of the benefits, 11.27 million. After that, you go for the present worth of the cost. We have the initial cost, so we put it exactly the same it is. And after that, we have annual maintenance for 15 years, that it gives you this amount. So the ratio comes with 1.122. That is a good ratio. So it means that the Defender now is right turn lanes. Gives us more than the cost we invested over it. Okay, we continue this analysis for going to left turn lanes, but we do it in an incremental fashion. So we go and calculate the BC for the incremental values that we have. So for the benefits, when we check here, the incremental is 0.6 million for 15 years. So here we calculate the present value and also this benefit that is already present value. So we come up to these numbers, and also for the initial cost we have 3 million and annual maintenance. So again, we need to get the present worth of this 75k, and the ratio is this one. The ratio is less than 1. So the extra amount of investment we do for the left turn lanes project, that is 3 million more on the initial cost and also 75k annually for 15 years for the maintenance, it doesn't give us back at least the same level and amount of investment we have devoted to this case. So we are not gonna go with that. We are just gonna stay with right turn lanes, and that's the winner.